Hello everyone, this is Yutanshi from CSIT. Today I'm going to tell about software engineering for machine learning applications, the road ahead from software quality assurance and testing. Introduction. Personal computing, the internet, the web, mobile computing, cloud computing. Nary a decade goes by without a disruptive shift in the dominant applications domain of the software industry. The latest trend to hit the software industry is around integrating artificial intelligence capabilities based on advances in machine learning. Machine learning refers to statistical modeling. Machine learning refers to statistical modeling for reasoning, problem solving, planning, and learning, and among others. Software engineering is the branch of computer science that deals with the design, development, testing, and maintenance of software applications. Software engineers apply engineering principles and knowledge of programming languages to build software solutions for end users. Software engineers design and develop computer games, business applications, operating systems, network control systems, and middleware to name just a few of the many career paths available. A career as a software engineer can be both fun and challenging with the opportunity to work in almost any industry, including large and small business, government agencies, non-profit organizations, healthcare facilities, and more. And as technology continues to evolve, the need for software developers continues to grow. Many companies are also shifting towards hiring software engineers who work from home, allowing for increased flexibility and more opportunities to enter the field. Software product updated requirements, system design, code design, deployment, system analysis. Some common job titles for software engineering includes applications architect, developer, database administrator, computer applications engineer, mobile developer, program manager, programmer, project leader, quality assurance analyst, software engineer, software quality engineer, system analyst, system developer. Software engineering for machine learning. The need for adjusting software engineering practices in the recent era has been discussed in the context of hidden technical depth and troubleshooting integrative AI. This works identifies various aspects of machine learning, system architecture, and requirements which need to be considered during system design. Some of these aspects include hidden feedback loops, component entanglement and eroded boundaries, non-monolithic error propagation, continuous quality states, and mismatches between the real world and evaluation sets. The goal of this work is to uncover detailed insights on machine learning specific best practices used by developers as Microsoft. We share these insights with the broader community, expecting that such takeaway lessons can be valuable to other companies and engineers. Software and machine learning projects life cycles, DevOps. Code, plan, build, test, deploy, operate, monitor, release. System accuracy. The first topic concerns the accuracy of systems built using machine learning and AI models and the responsibilities of engineers building them. For examples, one keynote speaker mentioned three categories of AI research: building programs that intimate human behavior to better understand human thinking, building programs that play games well, demonstrating that practical companies products can use the same methods that humans use, risky and often naive. They can also used in the psychology research, challenging and fun. Stages of machine learning. Machine learning is a subset of artificial intelligence that allows computers to learn from data without being explicitly programmed. It works by building models using large amounts of trained data and then testing those models against new data to see how well they perform. There are many different programming languages that can be used for machine learning. However, the most popular ones include Python, R, and Java. Machine learning is an approach to solve problems that are not easily solved with traditional methods. It is a way of building computer programs that make use of ability of computers to learn from examples and data. It can be used for many different types of applications, including speech recognition, image recognition, natural language processing, and autonomous driving. Stages of machine learning includes collecting data. As you know, machine learning initially learns from the data that you give them. So in this stage, we are collecting data to train the model. Second step is preparing the data. After you have your data, you have to prepare it. The most important part is cleaning and transforming it so that we can make use of it. Third step, choosing a model. The first step in any machine learning project is to choose the model you want to use. Models range from simple linear regression to more complex deep learning models. Step 4, training the model. In this step, we will train our model using labeled data and then test it on new unlabeled data. We can also use to feature engineering here like discretization or dimensionality reduction for accurate predictions. Step 5, evaluating the model. In this step, we compare our predictions with ground truth and decide whether our model works or not. Step 6, parameter tuning. This is one of the most important steps in machine learning because if you don't tune your parameters properly, then your model will be useless or worse. Step 7, making predictions. In this stage, we make predictions about the future. We use the learning algorithm that has been trained on data with known outcomes. Machine learning is used in software development to improve the accuracy and reliability of the software by using algorithms that identify patterns, classify data, and make predictions. It helps in identifying the errors in the code that could lead to bugs and other problems. Machine learning can also be used to predict future events based on user behavior or historical data. Machine learning and artificial intelligence and its implementation. One of the most common uses for machine learning in the energy industry is forecasting. Forecasting involves predicting future events based on past events. In the wind energy sector, machine learning can be used for three main purposes. Predictive modeling. This involves using historical data to predict future events or trends. Natural language processing NLP. NLP helps machine understanding human communication better by understanding what words means and how they are related to one another. Step 3, data analysis. By analyzing large amounts of data, machine learning can help identify patterns and insights that would otherwise be difficult or impossible to see. This is the workflow of machine learning. Requirements, data collections, data cleaning, data labeling, feature engineering, model training, model evaluation, model deployment, model mounting. There are total 9 stages of the machine learning. Software engineering process. The changing application domain trends in the software industry have influenced the evolution of the software process practiced by teams at Microsoft. For at least a decade and a half, many teams have used feedback intense agile methods to develop their software because they needed to be responsive at addressing changes customer needs through faster deployment cycles. Agile methods have been helpful at supporting further adoption. For example, the most recent shift to be reorganized numerous teams practices around DevOps, which better matched the needs of building and supporting cloud computing applications and platforms. The change to DevOps occurred fairly quickly because these teams were able to leverage prior capability software engineering processes. Software engineering application bugs, download, install, network, language, script, update. There are 8 stages in software engineering processes. Categorizing and detecting mismatch in ML enabled systems. Here are some examples of mismatch in machine learning enabled systems. Computing resource mismatch. Poor system performance because the computing resources that are required to execute the model are not available in the production environment. Data distribution mismatch. Poor model accuracy because the training data doesn't match the production data. API mismatch. The need to generate a lot of glue code because the component is expecting different inputs and outputs than what is provided by the system in which it is integrated. Test data mismatch. Inability of software engineering to properly test a component because they don't have access to test data or don't fully understand the component or know how to test it. Monitoring mismatch. Inability of the monitoring tools in the production environment to collect machine learning relevant metrics such as model accuracy. Machine learning is the discipline that studies methods for automatically inferring models from data. Machine learning have been successfully applied in many areas of software engineering, from behavior extraction to testing to bug fixing. Furthermore, the outcomes of given machine learning algorithm may be used in drive changes in the software development lifecycle, meaning that software engineers can only benefit from being knowledgeable about their machine learning counterparts. Software engineers can only benefit from being knowledgeable about their machine learning counterparts. Applications of machine learning: automatic language translation, image recognition, speech recognition, medical diagnosis, stock marketing trading, online fraud detection, traffic prediction, self driving cars, product recommended action, email spam and malware, filtering, virtual personal assistant. Machine learning disadvantages: data privacy and security concerns. While machine learning relies heavily on data, the collection and use of data raise privacy and security concerns. Initial cost and resources, lack of interpretability, dependence on data quality, ethical and bias concerns. Advantages and disadvantages: easily identify trends and patterns. No human intervention needed. Continuous improvement. Handling multidimensional, multivariate data, wide applications. Disadvantages: high error susceptibility, data acquisition, time and resources, interpretation of results. Conclusion: many teams at Microsoft have put significant effort into developing an extensive portfolio of AI applications and platforms by integrating machine learning into existing software engineering process and cultivating and growing machine learning talent. In this paper, we described the results of a study to learn more about the process and practice changes to undertaken by a number of Microsoft teams in recent years. From these findings, we synthesize as a set of best practices to address issues fundamental to the large-scale development and deployment of machine learning applications. Data privacy and security concerns. While machine learning relies heavily on data, initial cost and resources of the data raise privacy and security concerns. The outcomes of a given machine learning algorithms may be used to drive changes in the software development lifecycle, meaning that software engineers can only benefit from being knowledgeable about their machine learning counterparts. Software engineers can only benefit from being knowledgeable and their machine learning counterparts. better paths and software engineering ranging from behavior extraction to testing to bug fixing. From these findings, we synthesize a set of best practices to address issues fundamental to the large scale development and deployment of machine learning based applications. We presented a machine learning process maturity metrics to help teams self assess how well they worked with machine learning and offer guidance towards improvements. Machine learning has been successfully applied in many areas of software engineering, ranging from to testing and debugging. Finally, we identified the three aspects of artificial intelligence domain that make it fundamentally different than prior applications domains. The need to generate a lot of glue because the machine learning component is expecting different inputs and outputs than what is provided by the system in which it is integrated. Their impact will require significant research efforts to address in the future. Thank you.